Hello everyone, I am Rana. In this lecture I am going to give examples of finite differences. Before that, let us see what are the differences of a polynomial. Suppose that we are taking a polynomial f of x which is of degree n and the x values are equally spaced. Then the nth forward or backward differences are constants. Hence, n plus 1, n plus 2 and so on or forward or backward differences will become 0. Simply this can be written as delta power n f of x is equals to c. Delta power n plus 1 f of x, delta power n plus 2 f of x and so on will become 0. Let us see an example. We are taking f of x as x square and we are assuming x values are equally spaced which are differed by the length h. So that the x values can be taken as x, x plus h, x plus 2h and so on. Hence the corresponding function values will be f of x plus h, f of x plus 2h. Nothing but x square, x plus h whole square, x plus 2h whole square and so on. For this x and y equal to f of x values, let us form a difference table. We are listing out x values x, x plus h, x plus 2h, x plus 3h and y values as x square, x plus h whole square, x plus 2h whole square, x plus 3h whole square. There are 4 values, we get 3 differences in the difference table. Let us see first forward differences. Successive minus preceding. X plus h whole square minus x square. X square gets cancelled so that we get 12h plus h square. Similarly, successive minus preceding. X plus 2h whole square minus of x plus h whole square. X square gets cancelled. And here we have the term 4xh minus 2xh will be 2xh. And here 4h square minus h square will be 3h square. Similarly, for the next two successive y values, we get 2xh plus 5h square. This is the difference of x plus 3h whole square minus x plus 2h whole square. These are the first forward differences. Similarly, we can take the differences of these values so that successive minus preceding is given by 2h square. Again, successive minus preceding, we are getting 3h square. As we have taken a second degree polynomial, the second differences are constant. This is we have already discussed that f of x is of degree n, then nth forward or backward differences are constant. We have taken a second degree polynomial, so second forward differences are constant. So that higher order differences all will become 0. That's what we got in this difference table. Let us see some examples on finite differences. Construct a forward difference table for the following data. We are given 4 data points of x, y. For this, we can get 3 differences in the difference table. Let us write the difference table. We are listing out the given values of x and y here. To form difference table, we take the differences of y values. We follow only one pattern, whatever the values of y, successive minus preceding. 0.174 minus 0, which is equals to 0.174, 0.347 minus 0.174, which is equals to 0.173, and 0.518 minus 0.347, which is 0.171. These are the first forward differences. Again, we can take the differences of these values. So, we follow pattern. Successive minus preceding. 0.173 minus 0.174. We are getting minus 0.001. And again, successive minus preceding. 0.171 minus 0.173, which is equals to minus 0.002. Again, we can get one more difference. To get that, we take the difference of successive minus preceding. Minus 0.002 minus of minus, nothing but plus 0.001. We are getting minus 0.001. We are asked to construct a difference table. That part is over. Let us see another example. Construct a forward difference table for y is equals to f of x, that is equals to x cubed plus 2x plus 1 for x equal to 1, 2, 3, 4, 5. So we are forming the difference table. X values are listed here 1, 2, 3, 4, 5, and we are finding corresponding y values from the given polynomial x cubed plus 2x plus 1, where we obtain those values as 4, 13, 34, 73, 136. There are 5 data points. So we will get 4 differences in our difference table. Let us form first forward differences. We get from y values. Successive minus preceding. 13 minus 4 is 9. Again 34 minus 13, 21. 73 minus 34, 39. 136 minus 73, 63. Again, we take the differences of these value, first forward difference values. 21 minus 9, successive minus preceding, 12. 39 minus 21, 18. 63 minus 39, 24. Again, taking the differences of second differences, we get third forward differences. Successive minus preceding, 18 minus 12, 6. And successive minus preceding, 24 minus 18, 6. For this third forward differences, we again take differences. 6 minus 6, we are getting 0. That is the fourth forward difference. Let us see another example. By constructing the difference table and using the second order differences as constant, find the sixth term of the series. 8, 12, 19, 29, 42. Here we are given that first term, second term, third term, fourth term, fifth term. Which term is nothing but that is x, and number in that series taken as y values. So in this problem, x values should be taken as terms, first term, second term, and so on. So x values will be listed out as 1, 2, 3, 4, 5, 6, and y we let us see third example. By constructing a difference table and using second order differences as constant, find the sixth term of the series 8, 12, 19, 29, 42. There are 5 known values of y. The next value is to be determined. We are given the condition that second order differences are constant. So the value in sixth position is to be determined. So in sequence, term is nothing but x value. We need to take them as x values. So x values are listed out as 1, 2, 3, 4, 5, 6, and y values which are already given as 8, 12, 19, 29, 42. The term in sixth position is to be determined. Let us take the differences first. First order differences. Successive minus preceding. 12 minus 8, 4. Successive minus preceding. 19 minus 12, 7. Successive minus preceding. 29 minus 19, 10. 42 minus 29, 13. K minus 42 will be as it is. So using first forward differences, we get the second forward differences. Successive minus preceding. 7 minus 4 is 3. 10 minus 7 is 3. 13 minus 10 is 3. K minus 42 minus 13 is nothing but K minus 55. We are already given that the second differences are constant, as all the differences are equal to 3. This K minus 55 also must be same as 3. So that K is equals to 58 we are getting. K is equals to 58 is the sixth term in the given series.